Hi, I'm Jeff Simon, Director of the Applied Physics Laboratory at the University of Washington. The laboratory is renowned for its seagoing research programs. The feature you are about to watch gives us a look at an expedition in the North Pacific led by oceanographer Jim Thompson. He and his team set out to search for intense winds and large waves and to measure the cascade of energy from wind to waves to turbulence in the ocean generated by wave breaking. Like many APL-UW research programs, Thompson's research spans fundamental physics, instrument and sensor development, and the application of findings to real-world problems. In this case, to improve wave forecasts on the open ocean used by the Navy and the Merchant Marine.
Scientists from the Applied Physics Laboratory at the University of Washington set out for the North Pacific in search of rough weather, intense wind, and large waves to study the balance of wind and wave energy. The goal, to improve notoriously unreliable wave forecasts.
This project has been to study wave breaking in mixed seas, and that's a sea that has both swell, has waves that are old and big and long, and then has waves that are small, short wind waves that are made locally. There are very few measurements of waves in the open ocean. We don't really know how well the forecast models do. There's still a lot of room for improvement.
Wave spectrum.
Jim Thompson chronicled the expedition for the New York Times Scientist at Work blog.
Today we arrived at Ocean Station Papa, which is one of the oldest measurement sites in the world. Since 2010, we've had a mooring at Station Papa, our wave rider mooring. That's the mooring that we're here to recover and replace. During this experiment, the largest waves we saw were 4.5 meters, almost 5 meters, which is still a very large wave and contains a lot of energy and is really representative of most of what's happening in the ocean a lot of the time. You know, the maximum winds we observed were 30 knots. Again, that's really representative of a rough day on the ocean. Till our mooring was deployed 2 years ago, there were no measurements of the waves at Station Papa. Over this 2-year time series, we're able to see what is the long-term result of this breaking process. And the long-term result is to keep the waves in balance with the winds. So when the winds become strong and a storm comes through, that's a lot of energy being put into the ocean. But a very large fraction of that is actually going directly into breaking. We call that equilibrium.
On a day when we were taking a lot of data, when there was good breaking going on, we would throw out 2 swifts and one of the small wave rider buoys.
A swift. It's a buoy that drifts and moves with the waves. And the idea is to make all of our measurements in a reference frame that follows the waves. So you move with the wave and then you measure the breaking in that reference frame rather than staying put in one place and watching the wave go by.
That's where the coupling of the swift measurements and the video measurements is really key. The key thing really is that the swifts can say what's going on in the water. They say this is what the turbulence is doing, and the video that we take can say, and this is what waves are breaking that have created all this turbulence. The cool part about it was coming back from the cruise with all this data for the next 4 years of my thesis. That's been a really cool experience, and that's a really great thing about field work.
This experiment follows on work that we've been doing for about the last 5 years, most of it funded by the National Science Foundation in a different series of projects that have started from very small, pure wind waves on Lake Washington to the Strait of Juan de Fuca, which has some influence from the open ocean. And the energy really is the key thing that we're looking for, because when a wave breaks, it loses energy. So as the wave is formed, it gains energy from the wind. When it breaks, it loses energy. So the net of those two things is what gives you a wave field a day later. Right? So if we want to improve a wave forecast for the Navy or for the Merchant Marine or for anyone, we need to understand how much energy is going into the waves and how much energy is coming out of the waves. So we need to be able to do that across all different wave sizes and shapes.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.